Session is to continue with OWASP Top 10. The next major vulnerability, it's called security misconfiguration. Security misconfiguration could happen at any layer in your application. It could be a misconfigured operating system server. It could be misconfiguration of the database. It could be a misconfiguration of routers used in your infrastructure. An example of misconfiguration, sometimes people keep the default passwords, for example. When you install a database, there is, for example, a default username, admin username and password. And the operational team managing the application, they don't bother change that default password. So you might get an attack that will leverage those default configurations. So even in our homes, we buy, let's say, Wi-Fi router, we just plug it in and start using it with default username and password. In fact, sometimes we forget the password. We know it is the default. We can look it up in Google, say this brand and this model name, what is the default password? So we need to be this is an example of misconfiguration. So the idea here to prevent this is you do what is known as hardening. Hardening of the servers and all the components you are using means anything you don't need, you disable it. Any service you don't need on the server side, any package that you don't need, disable it or remove it. Default password for sure, change them or remove those accounts that come by default. Of course, in here, the vendors and service providers are more and more aware of this risk, and most of the servers now and most of the application servers and databases, they come secure by default, but still you need to be careful here. Luckily, there are a lot of tools out there that can scan your environment and they can report to you some of these misconfigurations. We will see some of these tools towards the end of the discussion. So in here, you need just pay attention to this. And the challenging thing, it's gonna impact any aspect, any level of your application, including from the operating system to the web server, application server, database server. All of these could open a window of opportunity for hackers if they are misconfigured. Another thing to keep in mind, the web server, when you are running the web server, you should run it under an account that's not an admin account. When a user is accessing an application, the application is running on a server, on a web server, and this web server is running under an account. And this account has some privileges. It can read and write from some files and locations. It has access to network resources. You need to make sure that the server is running under a regular user with limited privileges. You only allow this user under which the server is running limited privileges, only the privileges that are needed for the application. So be aware of this. This is the 6th OWASP Top 10 vulnerability, which is security misconfiguration. The other very common and very interesting vulnerability is called cross-site scripting, XSS. So this cross-site scripting, the idea of cross-site scripting is that I think it's easier to explain it through an example. Then I'll come back to this. So what happens is, let's say you go to Qatar Living as an example, or you go to a website where you can advertise jobs. So you get a window, an editor where you type all the details about the job, and then you submit those job details to the server side. And the server will store those details on some database or a file. And then visitors looking for jobs, they will search that job offering website, and then they will get those jobs to be able to apply for them. Now, this could be abused by hackers. What they can do, they can come to the job description, put some job description, and also put some malicious JavaScript code. What happened here, this, if there is no validation and if there is no filtering of this job description, it will make its way to the database. Now, the content will have some static content and it will have some script. The visitors of your website coming to check and see their and see the jobs, they will get the job description plus the script that the hacker has entered in the job description. And this script could be malicious. It could do a lot of damage. I will show you some small examples shortly. For example, it could steal your cookie. It can go even to the local storage, because this is a script running within your page. It is trusted. It can do whatever your genuine script that you wrote can do. It can go, for example, to your local storage and steal the ID token or the access token and send it to the hacker. It could deface the application. It could put some fake news or some inappropriate content or images. Or it could, even worse, it could pop up a little login window that looks similar to your own authentication window. And it can ask the user, type in your username and password, and this will be sent to the hacker and they can come and log in as you. So it's very dangerous and very widely, people are more and more aware of it. And also frameworks do not easily allow you to inject JavaScript in input boxes, but it is still there. And it can have very severe consequences. So let me try to quickly show you a small demo of it. Localhost 4000. This is my vulnerable application. It's called NodeGoat. It's available on GitHub. So I log in here as user 1. Then you can see here, this is my username, my first name and last name. Now I want to go ahead and change the profile. Oh, here is my profile. Here's my first name and last name. Now, the hacker, what they can do, instead of putting their first name, they will put a script instead. So what this script is doing, it is going to this profile menu link. Here is the profile. Can you see the profile? It's pointing to localhost 4000/profile. And what it's doing, going to that profile and changing the href to this evilsite.com. So every visitor of your website will have this injection. This script will run on their browser, and then that URL will change to some evil URL. And the users will just, when they go there, they will go to another website. And even worse now, with mobile devices, most of the time, even the address bar is not even shown. You might be landing in some other website without even realizing it. So let me show you. So I'll save this. Although browser has kind of detected it. Can you see there? Cross-site scripting, and Chrome has detected it, but still it went ahead. Anyway, let us go back to our website. And you can see here, you see this profile now? It's pointing to which website? evilsite.com. This is cross-site scripting. I go there, it is blocked by, luckily, another control mechanism. It's blocked by ITS. Okay, so let me show you another example. So we go to, now I have to know, to undo the damage, I have to know the real URL that was profile. And then I'll change this to another attack. In this case, it's even more serious. I'm going to read the local storage, the ID token, and I can send it through a HTTP post to another website for the hacker to enjoy. So here it is. So I'll go here, paste it here, save. It is detected by browser, but still the request went ahead to the server. So now if I go back, see here, ID token. Of course, this is not, I will not display to the user. I might do a post request to another website and post this one. So once I have this, I can basically log in as this user because I have the ID token, if you remember the authentication class that we did before. So this is very, very dangerous. So be aware of it. This is what cross-site scripting is. Very simple. The hacker will put some evil malicious JavaScript code within an input field. The content of that input field will make its way to the server, and the server will store it maybe in database or file. Visitors will come to your website, they will get the content from this database, and then they will get the genuine content with embedded script. That script will run within the browser. It is trusted because it's coming from your website, and it can do all type of damages, including defacing, changing the application, changing the user interface of the application, stealing sensible information such as cookies or ID token or access tokens, and a lot of other. It opens you have the whole JavaScript at your hand. You can do whatever you really wish to do as a malicious user. Okay, so that is basically the idea of cross-site scripting. The eighth vulnerability, which is new to the top 10, it's called insecure deserialization. Insecure deserialization. What this insecure deserialization means, remember, in our application, you have seen it all over. From the user interface, we can create JavaScript objects, and we serialize them. If you remember, when you post it to the web API, you take a JavaScript object, you stringify it, you take JSON.stringify, you put it, and then you send it to the server. What the server will do, it will deserialize it to be able to create the object again and do whatever it needs to do with the object. So this serializing and deserializing is so common these days when you build web applications. Now, this comes with some risk again. Some of these objects that are serialized and sent from the client to the server, they could have some malicious code embedded in them. So, for example, here I have this ordered line. This is kind of, I'm supposed to have a list of order lines. Instead, I am having a script as a value of this property. Can you see this script? Very dangerous script. It's looping forever. If this script runs on the server, on the Node.js server, what happened to the Node.js server? Will hang. It will not serve any other requests, because remember, JavaScript is a single threaded. You shouldn't run a long-running task on the thread, otherwise it will be unavailable for other requests. So what could happen? What could happen here is that the malicious user on the client side, they can intercept some serialized objects and they can change them along the way, or they can change them on the client side and submit this either an object that has been tampered with and changed. Let's say the user object. Let's say you have a user object. A user object usually has, let's say, user ID, first name, last name. It might have roles. As you could be an admin, or you could be a student, you could be an instructor. It's very easy for the malicious user to go to this user object and change the role from normal user to admin user. If you remember, luckily we have something called JW token, if you remember. We take the user object and we encode it into GWT token. And that GWT token is signed, if you recall. So if there is any attempt from the user to change the user object by, let's say, escalating their privilege from normal user to admin, and they send that object serialized, then the server side will detect it. Because luckily we have signed the message. If we didn't sign the message, then it's very easy for the hacker to tamper with the user object and elevate their privilege to a more to a user with higher privileges. So this type of attack, this secure deserialization attack, it could result in two major vulnerabilities. One, malicious users could tamper with and change the objects before they get, before serialize them and before sending them to the server side. So they could alleviate their privileges. The second, and even more serious damage, they could do remote code execution. They could send some code embedded within the JSON object. And then depending on how the server side or even the client side handles these objects, it could result into a remote code execution. I will explain this through an example, and hopefully it will make a lot more sense. So let me show you here some small example. This is a small example here. Let me just so here I have very simple object. It has a username, score, and the time spent. This is like let's say a game. And I might be playing game. After the session, I'm finished with the game. I'll send to the server side this piece of information: the game name I was playing, what is my current score, and how much time I spent. So I might serialize it, send it to the server. Let's say the server will deserialize it, and it might make use of it. After I deserialize it, I can make use of it. I can take the username and put it in. You see here, I have on the page, I have two headers, header 2 and 3, and I have a div in here. So what is this doing? It is dynamically reading data from the deserialized object and assigning it to these elements. So assigning the username, assigning it to this header 1, the score, assigning it to this header 2 element, and the time spent is displayed in this div. So it is harmless, nothing really fancy here. We have seen this type of code before. And let me run it. 42, which is the username basically, the score 550, and the time spent. Yeah, no problem. So somebody now wants to deface your application, want to put some maybe political message or some fake news, or they can put some inappropriate content, inappropriate images. They can do so by, they might intercept, a hacker might somehow intercept this message and change it. Or from the client side, maybe they might be able to change this message. So here is a small example of changing this message. Same structure as the original object, but the content is very malicious. So the username, I changed it to this text. The score, I changed it to this infinite loop function. And then this time spent, I changed it to an image. No change to the code whatsoever. Everything is still the same. And basically, because I'm not careful here about validating the deserialized message. For example, validating means that the score is a number. I'm getting a string, I'm not validating. I'm just taking it and using it as it is. It's even worse. Have a look at this. I could remember this baby developer using val to convert from a string to a number. They could take the score and trying to do val on the score. And unfortunately, the score that has this infinite loop. And what will happen now, it's an infinite loop. And if this happens on the server side, it will be an infinite loop going forever, and the server will just basically be blocked. Let's try now. See here, that content becomes harmless because the encoding has changed less than or less than and greater than, has encoded them, and no longer the JavaScript can really take place, or the HTML tag become harmless. So URL encoding, if it was a normal string, it will show up. So if I, let's say, if I go ahead and put my original message, I will still get the intended values. Intended values is no problem whatsoever. I see them as I expect. But any malicious content will be encoded and it will become harmless. So URL encoding could be a simple solution to avoid this. So in here, just to remind you very quickly, so insecure deserialization really means that when the user is sending us some objects that the server or the client will process, this object has been serialized. When we deserialize them to use them, we should be very careful because some properties could have been tampered with, and they can tampered with for two major reasons. Either the attacker is trying to erase or elevate their privilege from, let's say, from normal user to admin, or they are trying to trick the server or the client to do some remote code execution. So we should be careful, and one way to avoid this is to digit any sensitive objects that could be tampered with. Let's say a user object. You should be very careful. You should sign it before you send it to the user. And JW token that we've seen in last session will help us to do so. So if the user tampers with the user object and sends it back to the server will reject it because it says the signature of the new object does not match the signature included in the JW token, and the verification will fail. The other thing you can do is you try to encode, especially on the client side, you try to encode the properties from JSON objects before you display them or inject them into the HTML page. You can also do validation. An example, the score, I'm expecting the score to be a number, and suddenly it becomes a string, where it becomes like a script. I should just reject it. Luckily, a lot of frameworks that we are currently using, like Vue.js, it will do some of this for us. Because Vue.js, if you remember, it has vModel, for example. It will at least alert you or try to have some built-in auto-encoding of content so you don't fall into this type of attacks. So here is another small example. Remember this injection attack? It could happen not only from the user interface in the login screen. This SQL injection attack could also happen from a JSON object. So let's say here I have a JSON object, and instead of sending the username, I'm sending closing the single quotes and doing or with a condition that is always true. And then it get deserialized. This is the object after deserialization. And I take the username and concatenate it with my query. And then suddenly I am subject to SQL injection attack. So the idea here is don't trust just the user input from traditional user interface, but also you should be careful and validate the input even when you are receiving objects, serialized object, not just user input. Okay, so number 9 attack is also very widely widely available out there, which is using components with known vulnerabilities. You know, in our course, for example, the amount of code that we wrote compared to what we are reusing, maybe we wrote less than 10%. Most of the functionality is coming from components that we just do. For example, in our case, we did npm install, and try to install third-party component to make our life easier as developers. But that comes with a cost. Any vulnerability in such components, you inherit it. Your application will inherit that vulnerability. So you need to be careful. You need to look around when you have, you cannot like start from scratch. You will definitely use other people's components, but go with the ones that are popular, widely used. Even if there is some vulnerability, it will be quickly discovered and fixed. Also, if there is a fix or there is a patch released by such component, you should quickly go and grab it and apply it. Because especially these known vulnerabilities are published. Everybody knows them, including hackers. So it's a race between the hackers and the people taking care of the web application. And this applies to all layers, from the operating system to database, to web server, to components that you are using. All those could be vulnerable. So you might be investing a lot into what you have full control of and you are well protected. But some of the components could have these vulnerabilities and you are suddenly also vulnerable. So, and the impacts could be serious. If some component you are using is vulnerable to cross-site scripting, your application is also inheriting this vulnerability. So the idea here is to quickly apply patches and to be careful which component you select and use, not just any component that from unknown users or that has very little number of downloads. You should do your homework before you use certain components because it might have even sometimes maliciously embedded vulnerabilities to basically increase the number of victims. Now, this is quite easy to understand, straightforward, but unfortunately it is still widely kind of available vulnerability. The last one that I want to discuss here is insufficient login and monitoring. Insufficient login and monitoring. Lots of attacks could be prevented, or at least their impact could be reduced if we are carefully monitoring our application and logging important events. For example, if there is a failed login, the application should log that error. If somebody is trying to log in 2-3 times and they fail, it should be logged. So we can see that from the log, we can see that our application is under heavy attack from people trying to brute forcefully log into our application. Another more interesting examples, let's say if somebody managed to hack into the server side and they start stealing information, basically downloading lots of files from your web server. If you have a good monitoring tool that monitors the bandwidth utilization, and suddenly you see the outgoing bandwidth is rocking and you have more traffic than usual, this could be an indicator that somebody managed to get into your server and they are downloading lots of files from your server. You could be an early alert for you to take some action, to investigate and take some action. So there are two problems. Either the application does not do any login. Login here means who did what and when, especially for sensitive actions. If somebody is, let's say, in a financial application transferring some big sum of money, you should log it. You should log the time it was done, who did it and when, who did it and from which computer, for example. All this should be logged, and the log could be analyzed to identify some potential frauds. If somebody is doing it after working hours, this should raise an alert to you so you can investigate it. So you should invest in some logging and monitoring for you to detect attacks and attempted attacks and try to do something about it before damage is done. So here are some examples I just explained. let's say an attacker has installed some malware or some crypto miner on your server. So the server CPU usage definitely will go much higher than before. So if you have some monitoring tool monitoring your CPU usage and reporting to you unusual CPU usage activities, this could be an early warning for you to go and check what processes are running on this server, why suddenly I'm getting much higher CPU usage. And you could put your hand into this malware or this crypto miner that is installed on your server. Same thing as explained for downloads. You could monitor.
Someone is using your CPU for mining data?
Yes, for mining, crypto mining. Yes, they could manage to get into Alaikum Salam. 2 minutes, please. Okay. So, but unfortunately, because of the lack of monitoring and login, lot of these attacks go unnoticed. In average, it has been reported at least 200 days, almost more than half year goes, and nobody is noticing that there is an attack going on. And sometimes it's very late. Not only this, login is very important because even if the attack happens, you need to know what happened, what the attacker did. If there is no login, you will not be able to recover and fix the damage that the attacker has done. So login is also important for what is known as digital forensics. You investigate the incident that happened so for you to be able to recover from it. So basically, those are the top 10 that you need to be aware of. There are luckily also some tools that you can use to help you discover these vulnerabilities. There's a commercial tool very well known called Burp Suite. This is a commercial one. There is a free version of it as well. And there is an open source tool, OWAP. It's a very nice tool that can help you to do this. We might explore this further. Those of you doing security course, we might go into much deeper into this. So this is just to summarize. You should be, as a developer, you should be aware and understand these threats. And you can see many of them could be prevented by validating the input. It's critical to validate the input and not trust the input from users and use it directly. This misconception, you should be very much aware of it. Security by obscurity, if the user does not see it, it doesn't mean it is secure. You should really verify the authorization. You should read and follow the recommendations, the security recommendation for your platform. If you are using Vue.js, there are recommendations for your Vue.js. For Node.js, some security recommendation. Try to be aware of them. And there are tools that can help you discover these vulnerabilities and do some actions to fix them or remove them from your implementation.